Modern global shipping relies heavily on threading massive, fully loaded vessels through incredibly tight and unforgiving coastal choke points. The physics involved leave zero margin for error. A fully loaded cargo ship carries immense forward inertia, often combined with hazardous materials, meaning it cannot stop or turn quickly if an obstacle suddenly appears in a narrow channel. To organize this inherent chaos, maritime authorities rely on a system known as Vessel Traffic Services, or VTS. VTS operates as a dynamic control layer, extending far beyond the passive monitoring of radar returns. It provides the legally backed framework necessary to identify and resolve potential collisions before the physics of momentum make them unavoidable. A modern VTS operation is the seamless merger of multi-sensor data fusion with strict international regulatory authority. The legal foundation for this system is codified in Regulation V/12 of the International Convention for the Safety of Life at Sea, known as SOLAS, which grants coastal states the authority to establish these services. This image of two massive container ships safely passing is the direct result of VTS operators actively dictating space allocation to mitigate catastrophic risk. By actively organizing space and establishing clear, mandatory traffic clearances, operators ensure a constant and efficient flow of maritime trade. Through this legal framework, VTS transforms hazardous coastal waters from zones of open, autonomous navigation into highly managed traffic environments. This level of strict control is relatively new. Historically, coastal safety relied heavily on the individual judgment of ship captains, with little external regulation. This 1968 document, IMCO Resolution A158, shows early attempts to address port safety, recommending only voluntary port advisory services. Section A reveals the catalyst for this advisory: a rapid escalation in traffic at oil terminals and ports where noxious or hazardous cargoes are loaded. This photograph of the oil tanker Megara illustrates the physical scale of the vessels coming online during that era. The potential environmental damage from a ship this massive meant that voluntary advisories were no longer sufficient to protect coastal waters. As vessel sizes and traffic density climbed, the international community replaced weak advisory models with robust mandatory regulations, culminating in the modern IMO Resolution A115832. Section 3.1 of this modern resolution lays out a strict tripartite mandate. VTS is now explicitly required to ensure the safety of life, improve the efficiency of navigation, and actively support the protection of the marine environment. Escalating operational risks forced international maritime law to abandon voluntary advice in favor of mandatory, active traffic control. Before any legal authority can control a vessel, the VTS must first physically acquire and track it within a specific geographic zone. The system collects raw technical inputs from the waterway. It utilizes radar sweeps to detect physical mass, CCTV feeds for visual confirmation, and AIS data packets broadcast directly from ships. Modern control centers then fuse these raw data streams into a single unified digital nautical chart, appending critical variables like local weather conditions and specific cargo data. This data fusion is processed in facilities like the one shown here, where qualified human operators actively monitor multiple screens. This interface provides an extraordinary level of situational awareness. Operators can see the exact position, identity, intention, and movement vectors of every vessel. The critical operational transition occurs when the VTS moves from simply observing this data to actively intervening over VHF radio. These VHF handsets on the ship's bridge console are how the crew receives routine VTS instructions, like route advice, space allocation, and precise traffic clearances. Beyond routine scheduling, operators are mandated to intervene immediately during emergencies, issuing direct warnings if ships breach safe passing distances or exceed mandatory speed limits. The most advanced sensor network serves little purpose without a qualified human operator, legally empowered to challenge dangerous behavior the moment it occurs. This raises a foundational legal question. Under international law, what gives a local coastal operator the right to issue direct orders to a foreign-flagged vessel? The specific legal architecture that answers this is detailed in IMO Resolution A115832, which establishes the official guidelines for vessel traffic services. The authority chain begins at the top with the contracting government. This government is solely responsible for establishing the national legal basis for VTS within its jurisdiction. Power is then delegated downward to the competent authority, which translates broad national law into a specific regulatory framework. Below that sits the VTS provider. This organization is authorized to equip, staff, and execute operations within a declared area. At the bottom of this hierarchy is the participating ship. Foreign and domestic vessels navigating these zones are legally required to provide reports and comply with the instructions issued by the VTS provider. However, Section 7.1 of the guidelines reveals a deliberate paradox. Nothing in this system changes the ultimate responsibility of the master for all aspects of the safe navigation of the ship. If a VTS instruction contradicts immediate physical safety, the ship's master has explicit authority to disregard it, provided they report the justification for their actions. VTS operates through a rigid hierarchy of legal authority, managing macro traffic flow, while carefully preserving the autonomy of the ship's final decision-maker. Because this authority relies on immediate compliance, a critical vulnerability exists. Differing VTS procedures across different countries would cause dangerous confusion for shipmasters. To prevent this, operations are standardized by bodies like the International Maritime Organization, shown here at their headquarters. This section of the resolution highlights the International Association of Marine Aids to Navigation and Lighthouse Authorities, or IALA. Together with the IMO, they create unified global standards for training and system operations. Because of this harmonization, a VTS operator in the Middle East uses the exact same baseline logic, phrasing, and protocols as an operator in Europe. Strict procedural standardization is just as critical to preventing maritime collisions as the advanced radar technology tracking the ships. Vessel traffic services represent the precise synthesis of advanced sensor networks, active human intervention, and international treaty law. The system is not designed to replace the judgment of the master at the helm. Instead, it provides the critical, authoritative oversight required to manage the massive risks inherent in modern coastal navigation. By merging technology and law, VTS serves as the engineered solution to preserve order, life, and the environment in the world's most congested waters.